everyone, my name is Anu, and in this video, finally, after a lot of requests from you all, I have come up with my first video lecture on system design, which is going to be about scalability. So without further ado, let's dive right in. So have you ever wondered how apps like Netflix or Uber scale, or how Amazon is able to handle so much load? In this video, we are going to cover everything about scalability, starting from what scalability is, what is horizontal, vertical scalability, what are the different types of scalability, and what are some real use cases, and what is some real way through which engineers actually scale their systems. Now, this is going to be no whiteboard fluff, just real pure engineering, and I'll be talking throughout the video. So let's start off with what is actually scalability. So in simple terms, scalability is your system's ability to handle more load by adding resources. So imagine you go to a coffee shop which has just one barista. So that is low scale. But if you go to a coffee shop which has 10 baristas, let's say you go to a restaurant which has 10 waiters, that is a scaled restaurant, right? So in this video, we are going to talk about how systems actually scale, how apps like Netflix, Uber have done scalability. So first of all, now that we know what scalability is, it's the ability to scale to handle more users. So let's say you build an app, you have a small startup. So initially you are probably getting one user, 10 users, but slowly and steadily as the popularity of your app rises, there's many users coming. And your machine, like even when you see if you run something locally, it crashes even if you try to open it twice or thrice, right? So imagine what happens when you try to run something at scale, right? So the way through which you can scale is basically divided into two types. So the first one is horizontal scalability and the second one is vertical scalability. So talking about vertical scaling, what happens in vertical scaling is, let's suppose I have a simple HP laptop, okay? Now I want it to perform better. So what I can do probably is I can buy a MacBook, right? And what that will do is basically it will give me faster processing, the CPU will be faster, the memory will be faster. So vertical scalability is all about adding more resources into your existing computer, right? So your existing hardware, you probably throw in the resources, right? You try to scale it up. So instead of trying to get something new, you just try to make that particular machine bigger, better by adding more CPU, more storage, and more memory. But this is not actually very ideal because there is a cap. Even the best computers out there, supercomputers out there, they have a limit. So there's a ceiling through which you will pretty quickly you'll hit. So that is not very practical. So what do we do now? Well, there is a limit, and this is going to be very costly as well, right? So if you take a supercomputer, it's going to be very costly as compared to something if you take on the lower end. So what do we do now? The thing that we can do is, there are lots of computers, there's lots of servers, hardwares which are not as good individually, but there's lots of them and they're cheaper as well. So how about we actually take tens of those servers, those hardware which are not performing well, like mid performing, okay? And how about we take all of those and we try to distribute the load among all of them. So all of them combined can act as one supercomputer, right? And then you will have like smaller computers. So let's say I take 10 smaller computers, and all of them I combine it, and all of them, like if there's some load, one computer can handle one request, the other can handle some requests. So it's divided among them, and that is known as horizontal scaling. So vertical scaling is when you scale up, and when horizontal scaling is when you scale out. So you take tens of mid-performing, not very high-performing machines, but you try to scale it across that. You try to scale the request, all of that, because one of those computers cannot handle all of the requests, but those computers are good at handling smaller number of requests. So you distribute whatever requests you're having among all of that, and that is horizontal scaling. So now that we know what are the different types of scaling, so which is horizontal scaling, vertical scaling, also let's talk about the scalability dimensions. So scalability also has certain dimensions, what aspect you want to scale to, right? So there's user scalability, where you want to handle more users concurrently. And then there's geographic scalability, where you want to basically perform well across regions, right? So you want to perform well across different regions because you are a global service. And then there is data scalability. So you probably want to deal with growing data, right? So imagine the amount of tweets or posts that are there on X, right? So there's lots of data coming. Maybe the users aren't increasing. Let's say the same user who was inactive earlier has now started posting daily and is putting out across tens or 20 or posts each day. So as you can see, the data is increasing, but not necessarily the user. So that is going to be your data scalability. The other thing that is going to be in scalability dimension, which is the fourth thing, which is feature scalability. So you want to add more features without breaking the old ones, and that is feature scalability. So let's talk about some real life examples of how services actually use scalability, right? So let's start with Netflix. Every time you hit play on a movie, you're streaming high quality video data from a machine somewhere in the world, right? Now imagine millions of people hitting play at the same time across different time zones. So someone is in US time zone, someone is in Indian time zone, and not just time zones, there's different devices, there's different network conditions, right? So let's suppose one of them is using Geo, but one of them is using good another kind of 10G data that is actually available in US. So you can see the difference in network conditions as well. So what are the challenges that Netflix face, right? So one challenge is the huge traffic spikes, especially across evenings, because when someone people are binge watching Netflix, or across holidays, or when there are some new shows, like imagine when Stranger Things came out, how many people were actually streaming it. So that is one issue, which is handling the spikes, right? You want to scale, you want to make sure that no matter, you need to prepare for the worst case, you need to prepare for the case when it's unpredictable, and imagine when there's huge spikes. So systems, whenever you're building a system, you always think about the worst case, you never think about the best case. You want to think about what will happen, how will your system behave in the worst case, right? So one worst case is when it's holiday season, it's evenings, or when there are some popular shows which are getting released. Other thing is the high bandwidth requirements, right? You don't want to watch videos which are unclear, you want HD, you want 4K streaming. And the other thing is that you have global audience, right? So your audience isn't just constrained in India or US or Canada, it's across everywhere, right? So that will have some buffering as well. So if you remember, buffering earlier, it used to be a very common phenomena, but nowadays it's not as common a phenomena because systems have learned, services have learned how to scale. So the buffering concerns are not there anymore. So how does Netflix actually scale? So the first thing that Netflix actually does is horizontal scale with microservices. So we'll talk about microservice architecture versus monolith architecture in my future videos as well. So this is just the first video, but just to give you a brief overview of what microservice is, that you have, for every feature you have smaller services, you have separate code bases. For now, let's assume that. First way that Netflix actually scales is horizontal scaling with microservices. So every major function, right, whether it's recommendation or it's playback or it's billing, it has its own service, and so now they can scale independently. They don't need to worry about, okay, if we are scaling down billing, because so we need to scale down something like recommendation as well. No, these are independent, so you can scale up billing, scale down billing, and recommendation same, you can scale it up, scale it down. The second thing that Netflix does is it uses AWS cloud infrastructure. So Netflix uses AWS to automatically spin up more servers, more machines as demand increases, or spin it down. The third thing that Netflix does is CDN, so content delivery network. So what it does is basically it caches video content. So content delivery network, as I explained in my previous video as well, is about caching your data. So what it does is caches the user data closer to the user, right? So if there is a user in India, so to get that data for India, you don't have to make a request all the way to Canada. Instead, that data is stored somewhere near Mumbai. So that is what Netflix does. It has built its own CDN called Open Connect, which caches the video content closer to users. So this reduces the load on origin servers, and it also improves speed. That is how Netflix actually scales its system. So let's talk about another example. What about Uber? Right now, think about Uber. It's not just a taxi app, it's a real time logistics platform, right? At any given moment, it's tracking millions of drivers, riders, locations, and it's calculating routes, it's calculating ETAs, prices, and it all happens in real time, right? So, what are some challenges that Uber faces? The first challenge is real-time tracking and updates. It's not easy. Giving you live location, tracking, giving you the ETA, updating the location on maps, giving you updates, and if you share your location with someone, so giving them updates as well. The other thing that you want is you want high concurrency, right? So multiple users and drivers are interacting at once. The third thing that you want to make sure is regional surges. So let's suppose a concert is happening somewhere or there's a rush hour. In those cases, there's going to be surges. So again, the spike pattern, you're noticing that again. So the fourth thing that you have to do is highly dynamic data, right? So driver positions, there's traffic patterns, there's cancellations, so many cancellations happen. So you need to prepare for that as well. So how does Uber actually scale, right? Once is again the service oriented architecture, similar to the one we discussed with Netflix, right? Microservices. So pricing has its own service, routing has its own service, matching has its own service. The second thing is sharded databases. So sharded database is basically splitting your database, right? So what Uber does is splits user and trip data across regions so that it can handle load and reduce the latency. The third thing is very interesting, which is queuing systems, right? So one thing that we saw in Uber was the spikes, right? Same with Netflix. And both these services, they actually use queuing. So what queuing does is that even if you have the spike, right, the rate at which your request is coming, the rate at which the requests are coming through your service will always remain constant, right? So even if I have a flat line here and all of a sudden I have a spike, my system doesn't care about that because there's a queuing system which gives all of the requests in a constant way, right? It just shows everything across a constant way. So that is what it does. It uses queuing system, it uses Kafka for that, and it handles real-time event streams using that queuing system. The fourth thing that Uber does is auto scaling, right? So it automatically adds or removes the nodes, like as a compute nodes. So compute node is basically your machines only, your servers. It does it according to the load, right? So that saves cost as well. So when you have high traffic, you can scale it up. When you don't have high traffic, you can scale it down. So that is the four ways through which Uber gives you real-time traffic, real-time data by scaling their system. So what have we learned so far, right? How do we design for scalability? One is again, load balancers, right? You split traffic across servers. So I talked about all of these real life use cases. Now let's talk about the technical terms of this. So we talked about scaling it across, right? So load balancers you need because you want to split traffic across servers, but you want to make sure that not one of your server handles all of the traffic. So load balancers make sure that any traffic is distributed across all of these servers, right? It evenly distributed. The second thing that you want to do is stateless services. So you want to make sure that any machine, any server can handle the request. It's not like, okay, machine one handle requests for, let's say, user Anu. So the next time a user request comes from Anu, it has to go from machine one, even though machine one is, let's say, already handling requests of tens of different users. You want to make sure that the request Anu can go to any server. So you want to make sure it's stateless. It does not have any user information, whatever. So that is stateless service. The third thing that you want to do is database scaling, right? So you want to cache it. You want to shard it, you want to replicate it, you want to have multiple copies of it, you want to divide it, distribute it, and you want to also things that it can easily be given, which doesn't have to be computed, which is like static content that you can cache it. So that is database sharding. So that is the third thing that services should do. Now let's talk about the fourth thing that we discussed is queuing systems. So remember the time that I talked about the spikes that you have. You want to make sure that spikes are not there. You want to make sure that the requests are flowing in a constant, steady way. And that is your queuing systems. Now for queuing, you can use Kafka, you can use SQS. So they handle spikes smoothly. Fifth thing that you want to do is auto scaling, right? So you can use any of the cloud service providers like AWS, Azure, GCP, and you want to automatically add or remove services when the load is up and when the load is low. So that is the five things through which you can actually design for scalability. Now everything is good, right? So your system is highly capable, it's highly available, it's highly consistent. Now comes the trade-offs that you have to make with scalability. So one is the CAP theorem, which is consistency, availability, and partition tolerance. I'll talk more about CAP theorem in my next video, but to give you a brief overview, consistency means that I as a user should not care about which server I'm hitting. So every time you open Netflix, you don't know if you have hit the first machine or second machine, we don't know because we get consistent information, right? Availability, it should, your request should always have a non-failing response, right? So one trade-off is the cap theorem, right? The second trade-off is complexity versus performance. Do you want complex systems or do you want performance? Once is the second trade-off is the cost versus redundancy. If you want to, the best thing would be that, okay, let me just prepare for the worst case scenario right now and just scale out and have hundreds of servers. But then those, all of those servers, if they are, most of the servers, 80 or 50% of the servers, if they are sitting idle there, then what would happen is that there is redundancy, right? You don't need those servers and you still have it. So you need to think about that trade-off as well. Cost versus redundancy. The fourth thing that you need to think about is latency versus availability. So latency is the delay between when you make a request and when you get a response, and availability is always being, so if one of my servers goes down, the other should keep performing as expected. So that is the fourth trade-off that you need to think about when scaling systems. So let's talk about how companies actually evolve their scalability, right? So in startup phase, you would generally see a monolith architecture. Monolith means a single code repo. There's no, only one single service will handle everything. It will handle billing, it will handle user requests, it will handle recommendations, it will handle whatever the use case is. Everything is in a single code base, right? So in startup phase, you would generally have monolith, vertical scaling. In the growth phase, you will start breaking into services, right? Horizontal scaling, regional replication. And when you're mature, you will have a multi-region, multi-cloud, and auto-scaling infrastructure. So that is the way through which companies evolve their scalability depending on which growth they are in. So one of the myths that scalability the people have is that you need to scale from day one. No, you need to, premature scaling is a trap. You only need to scale when you actually see the need, you see the load, and you see that your service is not able to handle loads, users as expected. That is when you need to scale. You don't need to scale from day one. And people also think that scaling is just about adding more servers. That is not true. You need to architecture to support it. You cannot just simply add servers. You need to think about which service, even within a particular service, let's say recommendations, you might need to scale it out further as well. So you need to divide scaling in, you need to scale it further, you need to distribute it further. Servers, you really need to think about the whole engineering architecture of it. Let's, giving you a quick recap of what we discussed. We talked about what scalability is, what are the different types of scalability, what are the scalability dimensions, how real life use, we discussed real life use cases of Netflix, Uber. We also talked about some scalability myths, some scalability trade-offs, and what actually scalability means in real life. So that's it for the video. If you like this video, make sure that you like this video, comment and subscribe to my channel, and I will come up with the next video very soon. The system design playlist has finally started and I will be uploading videos at a regular pace, and I will see you in my next one. Until then, bye bye.